In this video, I'm going to give you an important and at times somewhat philosophical introduction to developing software for Flames. You may be someone who has already decided to use Flames, or you may be somebody who is trying out Flames for the first time and you want to figure out if it's the right software for you. Either way, I hope you find through these courses the information that you need to support your decision and to create a simulation that meets your requirements. Speaking of software requirements, let me begin by talking to you a little bit about the unique requirements that we have in the modeling and simulation industry. Requirements for simulations are different from the requirements for most other types of software. And I'm going to contrast it, say, with an accounting program as I go through this. Unlike accounting programs, the requirements for simulations are usually very diverse. Most accountants need the same type of software to support their job, so somebody can go out and write an accounting program and it'll meet the requirements of a lot of different accountants. It's not the case with simulations. Sometimes simulations are unique to a specific system, and only a handful of people in the world even know that that system exists. So they're not going to find a simulation that will meet their requirements out on the internet or find it anywhere else. Something else about our requirements is they're constantly changing. The world that we live in is constantly changing. The threats that we face are constantly changing. The systems that we have to simulate are constantly changing, being upgraded. So our requirements for simulation are also always constantly changing. And what that means ultimately is that we need a lot of different kinds of simulations. We can't just find one that will do everything. We need many different kinds of simulations. And even more than that, those simulations have to constantly be updated to be able to adapt to the constantly changing simulation requirements. All that leads to the fact that most of the simulations that are in existence today and that will be in existence in the future are going to have to be custom developed. So they are and they always will be custom developed. So if you have a set of requirements that that you can find a simulation that will meet those requirements, that already built, does just what you want to do, and your requirements are not likely to change, they're not likely to increase or be any different, so you don't have a reason to have to make changes to the simulation. So if you're in that situation, you can find a simulation that meets your requirements. By all means, just go buy it. It's almost always true that buying something is a lot less expensive and a lot less risky than developing something. But again, most people aren't going to be in that situation, as we've just talked about on this slide. So they're going to be faced with having to develop something custom. Now you've got a couple of different options when you do that. One of them is to go get Microsoft Visual Studio, install it on your computer, and start writing code. Just develop the simulation from scratch. And a lot of people, a lot of big organizations do that. They just start from scratch and try to build a simulation from scratch. Or they take maybe some existing simulation and try to make modifications to it. Another approach that gives you a lot of flexibility, just as much flexibility as you would have if you developed it from scratch, would be to build it on Flames. Flames gives you the ability to customize it to your specific requirements, but it's a framework, and so you don't have to do all the development yourselves. There are other simulations out there that call themselves frameworks, and I don't own the definition of the word framework, so there are certainly lots of legitimate definitions of the word framework. But in the computer science world, if you look at what framework means, the other simulations that call themselves frameworks are really fixed applications that have some level of customization that is supported. So they're customizable fixed simulations. Flames is not a simulation. It doesn't model, as you know by now, it doesn't model any real world systems. All those systems are custom developed outside of Flames, and it gives you the ability to plug in whatever system you want. So why would you use Flames? Well, first of all, a little bit more about why you wouldn't want to try to develop a simulation from scratch. You probably have heard of somebody named Eric Gamma. He's a software engineer. I believe he lives in Switzerland, or at least did. He made this statement that designing object-oriented software is hard, and designing reusable object-oriented software is even harder. And here's why. You have to find all the pertinent objects, factor them into classes at the right granularity, define class interfaces and inheritance hierarchies, and establish the relationships among them. It's hard to get that right. Well, with Flames, we've already done that. It took us a long time to get it figured out, but we can honestly say that we have it right. We have developed a reusable object-oriented system that lets you write reusable software. You maybe have heard of another guy named Grady Boots, another one of the masters in software engineering, computer science. He made this statement: a complex system that works is invariably found to have evolved from a simple system that worked. A complex system designed from scratch never works and cannot be patched up to make it work. You have to start over again, beginning with a working simple system. If you believe what Mr. Boots is saying, if you think he's accurate, then you know that you can't build a complex simulation system from scratch. Okay, so what do you get if you use Flames? Simulation that's developed based on Flames is almost always better, faster, and cheaper. And you've probably heard those words before. And probably you've heard people say, better, faster, cheaper, pick any two. You can get something that's better and you can get it quickly, but it's not going to be cheap. Or you can develop it quickly and you can develop cheaply and it's not going to be any good. Well, we believe with Flames, you get all three of those. And what do we mean by that? Well, better, we mean that with Flames, you'll get a simulation that is much more capable and much easier to use than building one from scratch or than using anybody else's simulation. We believe you'll be able to develop it more quickly than any other approach to developing the simulation. And we believe you'll spend a lot less money not only developing that simulation from the beginning, but also maintaining it and upgrading it as your requirements change and you need to upgrade the simulation. Another way to say that is that, and this is really the whole purpose for Flames, is we want to help you get a simulation that meets or exceeds your requirements in the least amount of time and money possible. So very capable simulation, you get the least amount of time and money that you have to spend to get it. So how do we do that? Well, these are the specific things that Flames does that will help you achieve those goals. The first one, and this is arguably the biggest one, or one of the two biggest ones, is it greatly reduces the amount of software that you need to develop. You need to develop, you need to test, you need to maintain, you need to update. You don't have to write a ton of software. You don't need to write your scenario editor. You don't need to write your mapping software. You don't need to write your memory management software. You don't need to write your scenario database software. You don't need to write 2D and 3D visualization, and on and on and on. That software is already written. It's very high quality. It's very well documented. It would take many, many years to be able to recreate the volume and the quality of the software that's available in Flames that you start with on day one. But there is software that you need to develop, and Flames gives you the flexibility to write that software. So you can plug in models of any type of system that you want, but you have to write that software yourself. So even there, we help save you time and money because we greatly simplify that software development. And one of the ways we do that is because all the design that we talked about previously that is so hard to do has already been done. It's already been proven. It's already very robust. It's been tried and tested. And we have the class hierarchy. We have all the class relationships. We have all the interfaces. We have everything all set up. It's very polished. It's very mature. It's very robust. It's already been done. You don't have to figure out any of that stuff. The risk is dramatically reduced. Plus, when you write your code, our objective is to keep the number of lines of code in the models that you have to write, to keep the number of lines of code as small as possible. We always look for, and we continue to look for ways to reduce the number of lines of code that you have to write. So the design is there, the structure is there, we have a whole bunch of utilities and features in the abstract classes that you inherit that do things for you automatically, that greatly simplify the software that you have to develop. And you'll see that as you get into the training classes, and particularly in the classes on entity model development. But it really, all of the training videos, you'll see this underlying theme that we're trying to simplify and add rigor and standardization to the software that you develop to make it as simple as possible for you to build the models that you want to develop. Another way that we save you time and money is in reducing and eliminating most software integration steps. So there's not a system that is any more easy to integrate software into than Flames. There are others that are similar in the way that we do things, but when you write your models, as you'll see, you write it and compile and link it into a DLL. You throw that DLL into a folder, you restart the Flames applications. The Flames automatically loads those classes that you developed into the system, fully integrates them in. There's no software that you have to change in Flames to recognize your system. It's plug and play, literally plug and play. Your software self-integrating, and it's very, very elegant the way that we do it. It saves tons of time and error-prone activity. And the last way is if you develop something, last major way, you develop software for Flames, it's going to be reusable on the next project because all of the software classes that you develop for Flames are actually composition independent. The way those systems get put together is specified in the scenario editor. It's data that defines the way the systems tie together. So you can write a model that you intend initially to use for one purpose. The next time you have something going on and say, hey, I have that model, I can use it again on something else. So this plug and play architecture lets you plug any combination of models in that you want and reuse the models that you've written before. So true software reuse is not a dream with Flames. It is fully supported, and all of our customers that develop on Flames are reaping the benefits of that. So how are you really going to make all this happen? Well, you need to complete the training classes. Flames is a big, complicated system. It has a pretty steep learning curve. There's a lot to learn. And if you've ever used another really powerful, robust framework, for example, maybe you've used one of the game engines like Unreal Engine, that's a platform for developing games. It's really big, it's really complicated, extremely powerful. There's a lot to learn, but it's worth it to go up on that learning curve because you have so much power available to you in Flames. There's so many things that it does for you automatically. And once you get up on that learning curve, you're going to be so productive in building the custom models and ultimately the custom simulation that you want. And that's why I built these training classes, is to not only is Flames free, but the training classes are free. We're doing everything that we can to make you as productive, make you as successful as you can be in writing your software. So complete the training classes. In addition, I know some of you aren't going to like this, but it's really unavoidable. Every single thing that you need to know about Flames is not covered in the training classes. We have a lot of information, and everything you do need to know about how to use Flames is covered in our documentation. We put a tremendous amount of work into the documentation, not as much as we have in the software, but a lot of work into it. There's a wealth of information there, and you need to take time to read it, especially the sections of the documentation that are relevant to the particular thing that you're trying to do with Flames, a particular type of model that you're trying to develop. Read the documentation. I mean, it's unavoidable if you're going to be successful at using Flames. In the documentation and these training classes, we're going to give you lots of guidelines, and some of them are even rules that you need to follow, instructions of what you need to do. Follow the instructions. Don't try to do it some other way. Learn how we say you should do it in Flames. Within your model, within your class, you've got complete flexibility to implement your algorithms and do things that you really want to do. If you're implementing the equations of motion for a missile model, or you're implementing a tracking algorithm for a radar, or you're building a radar model. Lots of freedom and flexibility to how you want to implement the internal workings of that. But when you want to plug it into Flames, you need to plug it in and integrate it and make it fit the way that we tell you to do it. And we have certain classes. We've got a class for cognition models. We've got classes for sensors. We've got classes for platforms. learn what our classes are, and make sure that when you write a certain kind of code, you're putting it in the right kind of class. Don't put sensor code inside of a cognition model. Don't put cognition code inside of a data processor model. Learn what the classes are, learn how they work together, and put the right kind of code in the right place. We have specifically designed our class hierarchy to mirror the real world and the systems that exist in the real world and the interfaces between them to be representative of the way that those real world systems interact with each other. So learn our classes, learn how they interface, follow our instructions for how you do things and how it all integrates into Flames. And then something that will greatly simplify things is look at the source code that we provide. We have a GitHub repositories that have all the source code to all of the component models, all the content models that we supply. Unlike other simulation systems, other commercial simulation systems in particular, all the source code is available for all of our models. Get it, and you'll learn in these classes that we always tell you to start with an existing model, either one that you wrote or somebody else wrote. We have a tool that you can use to copy that code and rename it to create a class of a different name. So a lot of the steps required to build a model are already finished because you're always going to be starting from a working model by copying that code. Study that code. That code is there to illustrate to you the right way to use Flames. Now, I'm going to go back to that follow instructions things. I'm going to harp on this just a little bit more. And to do this, I'm going to talk about hardware. So this is a modern graphics card. You've probably seen one of these before. The graphics cards have gotten really complicated and real capable. Well, graphics cards, no matter how big and fancy they all have this little set of connector right here. This is the way that the card plugs into the motherboard. When you're using Flames, you're basically going to be writing things that plug into Flames. So you're going to be writing light graphics cards. You're going to be writing different types of things that plug into Flames, and you can consider Flames to be the motherboard. And there's going to be the equivalent of this in software, this little connector here on how your classes integrate and plug into Flames. And that's done primarily through the interfaces that are defined by the abstract classes that you're going to inherit. You need to follow the rules, as I've already talked about, in implementing the classes so that you implement that interface faithfully. And I'm just going to mention something here. If you were a hardware engineer and you were going to be developing a graphics card, you would understand the importance of making sure that you know what all the little connectors on that connector do and what the spec is and exactly how to make sure information is passed back and forth on that connector exactly right. Nobody would have to persuade you about the importance of making sure you get it exactly right. You would know you had to do that. You'd be very careful to make sure you did it that way. And you'd make sure your graphics card conformed to that specification because it wouldn't work otherwise. Well, you can write software for Flames that doesn't conform to the specifications, and it will kind of work. And we've had lots of customers, not lots, but we've had quite a few customers that have gotten Flames. They really never really take the time to learn how to use it. And they take things that they've learned from other programming projects, and they just start programming and start writing stuff with Flames. They never learn about all the features that are available in the Flames system that will help them do their job. They don't know about certain subroutine libraries. They don't know what the class interfaces really are. They don't know how the classes really work with each other. One example we had, well, I'm not going to go off on that. I've got a couple of examples that are bad examples of how people just did weird things with Flames. The problem was when they got finished, it didn't really work out right. And they said, Flames is hard to use and Flames really couldn't do what we really wanted it to do and everything. Well, we went and looked in some of those cases at what they did, and they didn't follow the instructions. They ignored the features that were available in Flames. They wrote their own way of doing things. They didn't really understand how classes work together and everything. And they just went off and wrote something on their own according to what their own idea was. It would have been much easier to write in Flames, and it would have worked if they'd done it the Flames way, and it would have worked a whole lot better. So again, follow the training classes, complete the classes, read the documentation, follow the instructions, copy the Flames source code, and you're going to be able to get a Flames-based simulation that has better capabilities. You're going to be able to develop it faster and less expensive. So I hope this has motivated you to be real serious about studying taking these courses, and I hope that you'll learn a lot about it, and I hope you'll have a great experience with Flames, and you'll get a simulation that's better, and you'll get it faster and cheaper. Thank you for listening to me pontificate. You'll get an opportunity to do that quite a bit more in the videos that are ahead. Thank you for listening, and thank you for using Flames.